Hey, good morning, everybody. This is Noah over at Entertech, and we are going to continue our webinar on GeoAnalyst today, and we're going to go over pressure drop and get a little in depth with that. Again, if you have questions, feel free to type them into the chat box, and Jimmy will see those and answer them as he's on the fly, or we'll just wait till the end, and we can put those at the end of the session. Also, we have coming up on July 12th, it'll be another 2-week webinar, so then it'll follow on the 19th. We're going to go over loop length, which is a little more in-depth version, I guess, if you want to say, of GeoAnalyst. But yeah, I'm going to turn it over to Jeremy, and we'll get going here.
Thanks, Noah. Good morning, everyone. As Noah said, loop length is a more detailed version of GeoAnalyst. What I find guys really use loop length for is very detailed vertical bores or detailed ground loops or variable loads. That's what it's really good for. It's definitely a more dissected version of an energy analysis program, and you'll definitely want to check that program out. Sit in on that webinar and see what you can learn from that. But today, as Noah said, we're going to focus on the pressure drop portion of the GeoAnalyst program, and this also can be found at geoanalyst.net, just like the energy analysis program. So I'm just going to go ahead and get logged in. Now, in this screen, what you'll be able to do is, or in this function of the program, I should say, what you'll be able to do is lay out all of your ground loop piping and play with some different pumps, some different units. So we're going to go ahead and open up the GeoAnalyst example that we did last Wednesday. Now this will allow you to essentially lay out your ground loop, pick a different unit, one single unit, multiple units, whether you want to pick a 2699 or a couple of 116s or maybe a 32140, that variable speed flow center. What we can do is just open up our example. This is the GeoAnalyst that we did last week, and we've still got all of our systems in there, system 1, 2, 3, and 4. However, those systems do not feed automatically into the pressure drop section. So while I am under this file, GeoAnalyst example, this is my project name, and this is what my file is saved as. There are two separate parts of the program. So when I go into the pressure drop section, it's going to essentially begin at baseline 0 again. This is all fresh information that I have to tell it. It does not carry anything over from your energy analysis that you previously completed. But it functions much in the same way. We have a couple of different tabs across the top of the screen, and those different tabs are just going to advance us through the program. The first screen is system information. We're going to go ahead and select our antifreeze type. Say propylene glycol, 25%. The number of parallel circuits is the number of loop circuits that you have. So I'm going to go with a 5-ton example. And a central pumping station means that I've got one pumping station. If I had multiple units, it would be one single flow center or one single pump for all those multiple units. And so in this example, I'm only going to have one machine. I could leave it either way, central pumping or each unit has its own pump. It doesn't make a difference when I only have one unit. So I'm just going to take a look at the 2699 first. I'm going to go ahead and select 2 of the 2699s. I don't believe that one 2699 is enough pump for a 5-ton ground loop. We could look at it if you guys would like to, but I'm just going to start right here at 2 2699s. And then I go ahead and click the next tab, which is units. Now here I'm going to select one unit, and this will be an HYT 060. So again, for anybody that's GeoComfort, it would just be a GYT. Tetco would TYT. hydron module HYT. So we've selected our series, we've selected our tonnage. We've got 10 feet of hose kit between the flow center and the unit. And now here it's asking us for the feet of 1¼ PE pipe in both directions from the unit to the flow center. Most cases, we probably don't have any piping there. If you do hard pipe your systems or have anybody you work with that hard pipes your systems, you could just remove the hose kit and go ahead and install, let's say, 10 to 15 feet of 1¼ HD PE pipe. And that's defaulted at 1¼ in this particular section. On the next screen, I'll show you where we can change the size, but right here you are stuck at 1¼ and right here you are stuck at 1-inch hose kit. So just throwing out the basics, and then you advance to the next screen. So on the piping tab, what I'm able to do here is select the pipe size between the flow center and the wall penetration. So I'm going to click that. Notice here in blue text, what we've got pipe description is polyethylene SDR11 1/4. That's my description. So here is polyethylene SDR11. If you, for some reason, would do a Schedule 40 or a PEX ground loop, those options are here, but most everything is going to be done with polyethylene SDR11. So 1¼ pipe is the proper size I'd like to have selected there. So I go ahead and click select and then click OK. Now, what this is saying is between the flow center and the wall penetration, I've got 20 feet of hard pipe, 1¼ hard, HDPE. That's in both directions. So what this is saying is that I have 10 feet one way from the flow center to the penetration and 10 feet back. The next screen is actually from the wall penetration all the way out to the header. So let's look at a 150 feet. So this is going to be 75 feet from the penetration to the header and 75 feet back, because it lists in both directions. And then our circuit piping, total circuit length, let's just say 460 foot. A horizontal bore, some guys are putting them in at 460, some guys a little bit less, but in this example, I'm 75 feet away from the house where I begin a horizontal bore that is 460 linear feet of pipe in both directions, which would actually be a 230-foot bore shot. And the number of fittings in the system. Now this is the number of fittings that is all the way to the unit. So unit connection fittings, including the hose kit connection or the whatever fitting you've got at the unit, that maybe a 90-degree fitting, that's where we begin. And so from there, through any other 90-degree fitting, I do like to include some fitting penalty for the flow center, just because there's a lot going on there in the flow center. So I think 10 to 14 is a typical. We're going to go ahead and bump this out to 14. If you're using a GeoSolar header, we'd probably pull this back down to 10 or so. Just depends on really what you have going in your application. I know you don't always know exactly how many fittings are going out there, so you just kind of run through your brain and figure out what you're comfortable with. GeoSolar headers are a lot smoother than your typical linear header. GeoSolar headers will basically allow less pressure drop at the header point of your ground loop. So today's example, I am going to bump this out to 14. And now we just take a look at the pressure drop chart. So in the pressure drop chart, what we're going to see is that the nominal flow rate is 15, which is our target. That's our target flow. Our actual flow rate in this example is 16 gallons per minute. The total pressure drop on that ground loop is 42.1 feet of head. So what we're seeing here, just for anyone who may not recall or doesn't know, when you're sizing a pump, what you need to know is how big is the pipe, how far am I going to carry this water, how many gallons do I need to carry, and how thick is it? And all that information is all calculated behind the scenes on this program when you input that information, and it's telling us that it would take a pump that would be able to overcome 42.1 feet of head and deliver us 16 gallons a minute in this circuit would be our, our proper pump selection. So, basically, did I meet or exceed my nominal flow rate of 15? Yes, I did. I have 16, and that is 2 UP2699 pumps. Total loop fluid gallon, or total fluid in the loop is 94 gallons. Flushing requirements, this is your your flush cart. How big a flush cart would I have to purge this ground loop? You'd have to have one that would do 18 gallons a minute at 54 feet of head. If you can do that, then you'd be able to purge this ground loop out. And the total antifreeze required is pretty handy, 23 gallons of antifreeze. So, you need to take at least 23 gallons out there, plus whatever you want to account for in your flush cart, and maybe a little bit extra for your hoses. So that's how the pressure drop function works. I'm going to go back here and show you guys a couple of examples where we maybe would pick a different pump. The 32140. Let's take a look at that pump. Everything else is the same. So this is the variable speed flow center with the 32140. This flow center will give us 15 gallons a minute, and our target rate is 15 gallons a minute. However, we do get an alert telling us that our Reynolds number is too low. So what that means is that the turbulent flow in the ground loop is inadequate. Now, I've had contractors speak to this and tell me that they've got systems out there installed in this manner and they're functioning totally fine, and I don't disagree. But the program is going to turn this red and give you an error telling you that your Reynolds number is too low if you're below 2,000. And we do want to respect the Reynolds number, particularly with vertical loops or directional bore loops. Loops where the water doesn't spend a lot of time in the earth. It's very important that those few seconds that's in the ground, it gets the amount of heat that it needs to get from the earth. If we have a low Reynolds number, the water goes out cold in the heating season and it comes back still pretty cool. We increase the flow rate, it increases the turbulent flow in the ground loop, causing this temperature difference to increase, and you extract more heat from the ground loop. If you were to freeze time, dig out your ground loop, slice it up like salami, a low Reynolds number would look kind of like a tie-dye t-shirt. The middle of the fluid is not getting any heat transfer. The only part of that fluid slug that is getting any heat from the earth is the perimeter. So just keep that in mind when you're looking at this. Maybe I would want to go back to the 2699s, or if I really want to use the magnet variable speed 32140, I could roll the dice since this is very close to 2000, or I could change some things. I could go back to my piping circuit and say, well, the GeoAnalyst report actually told me that I don't really need this much pipe. I normally would install a 460. Well, let's say I install a regular 410 foot directional bore. That's going to make my 3/4 inch ground loop shorter. So that's easier to overcome. Let's just take a look and see if that assists our Reynolds number and pulls it above. Nope, doesn't help us enough. Still sitting at 1915. But you could come back through here and make small adjustments to your design. Could you start the bore a little bit closer to the house? Maybe you don't need to go out 75 feet. Maybe you could get 50 feet away. So then our total circuit would be 100. So now I've got less loop length and I've got less header length. Does that bring my Reynolds number up? No, it's not going to help us. So I would say it's not worth the change in that system. Let's go back to our original design. We're comfortable at that 460 foot directional bore, so we know that's good. I would probably just go back here. If you really wanted your Reynolds number to get up over 2,000, I would go to the system information screen and select 32140 with the 2699. That's going to give you a second pump to assist this 32140. However, the 32140 will give you the 15 gallons a minute that you're asking it to do. So I'm not sure Yeah, see here, they are showing us running both pumps. We will be running a 2699 and a 32140 will handle whatever the 2699 can't cover. And together they'll give us 18 gallons a minute on that ground loop and pull our Reynolds number up over 2,000. So just showing you the example, 32140 alone would give us the proper flow but low Reynolds. That's your call whether you want to install that with a 32140 or 2699. All right, so let's go back and take a look at some other options. I'm going to say that each unit has its own pump. This let's say is a different job. The first example I was showing you, should we pick a 2699 or should we pick a variable speed flow center? I guess before I move on, let me show you, because I know there's probably someone out there telling me do the 116. So let's go for it. Two UP26 116s on 5 loops. Same example. And we're good. So that shows you that the 2699s will give you the flow. The 26 116s will give you the flow and the Reynolds number. And the 32140 with the 2699 will give you even a little bit more flow and a higher Reynolds number. Now, it's not a problem to overflow the unit a little bit, but I wouldn't overflow it extremely strong. I would say just to kind of respect that water flow rate. We do have in our specification manuals some lower water flow rates that are acceptable, but we don't publish anything with heat of extraction or heat of rejection data at this higher flow rate. So the one problem that could cause you is when you do a performance test, you're expecting or having specifications for 15 gallons a minute, and your system is designed to flow at 17. So you need to reduce the flow to 15 in order to properly test this style of system here. All right, so back to where I was, just showing you guys the different pump options there. Let's take a look at multiple systems. Let's say this job or another job, you'd like to have multiple units. And on this job, we're going to go with 10 tons. I'm switching gears on you. Forgive me if you're confused on the last week's GeoAnalyst report. We selected a 4, 5, or 6 ton unit, and today we're going to talk about a 10 ton unit simply because I know a lot of folks out there are doing multiple units. So let's go ahead and say that we've got the same HYTO 60, but maybe they've added some radiant heat to this project. So we'll add a water to water unit. And since I've selected 10 tons of ground loop, for my example, I'll give you 10 tons of capacity. It will match the installations. So we've got a hose kit on each unit. I have 2 5-ton machines, an HYTO 60 and an HWTO 60. Both of those units have their own flow center, and both of those units are connected to that flow center using a 10-foot hose kit. And I'm going to leave this at the 2699s just to show you guys what will happen. So we move on to the piping section here, and I'm going to say this is the same thing. We have a flow center to wall penetration, 20 linear feet. It might be kind of tough to do, but we'll leave it at 20. And 150 feet from the structure, or sorry, 75 feet out and 75 feet back. So a total of 150 linear feet in both directions of header from my wall penetration all the way to my header pit. Same circuit length. I'm going to do a 460-foot circuit for maybe a directional bore. 14 fittings. Take a look at this. Okay, so now we're only getting 26 gallons a minute when our flow rate target, our nominal flow rate is 30, and our Reynolds number is too low. So the 22699s are not an adequate pump selection for this project. You can see that here. We don't meet our nominal flow rate of 30. We're only sitting at 26, and our Reynolds number is well under 2,000 at 1660. You're really rolling the dice, but you still get all the same information, 49.3 feet ahead. Total fluid volume in your ground loop is 164 gallons. 41 gallons of antifreeze would give you a 25% blend of propylene glycol. But this pump isn't going to cut the mustard, so we're going to back up to the system info screen, and we're going to pick, strange, I thought I selected the 226.99s. Let's take a peek. Yeah, same numbers. Back to system info, 26.99s. Now we'll take a look at the 26.116s. Same info. So those pumps are both limited out on this circuit. Let's go to the 32.140 with the 26.99. So now I have each unit has its own pump. HYTO 60 on one side with a variable speed flow center that includes a 26.99 pump to assist it for each unit. Let's check the pressure drop chart and see how we look. This pump is also at its limit. So I think what's going on here is that our piping circuit is too restrictive for these pumps. I'm going to go back to the beginning. I'm going to double check everything. Propylene glycol, 25%, 10 circuits. Each unit has its own pump. I'm going to go back to the 26.99s, and I'm going to show 2 of them. But everybody, what I want to do is make a difference in the piping size. Because now, problem here is that I'm sending 30 gallons a minute down an 1.25 inch pipe. So we'll go flow center to wall penetration, select pipe size. Let's go to 2 inch. Hit OK. And I'm going to do the same thing for my header from that penetration all the way out to the ground loop header pit, 2 inch. Everything else is the same. So I've gone back to the weaker pumps, the UP 26.99 pumps, our smallest ground loop pump that we typically use. But I've fattened up the header from 1.25 inch to 2 inch. Now we're getting the flow rate that we want, but our Reynolds number is still low. We're really, really close to 2,000 here. So I don't know that I would really be alarmed. So again, in this example, you could pick the 226.99s for each unit, or you could go back and just take a look. How much does a 116 team help me? So in this example, each unit's got 2 116s. That's the UP 26.116. And right there, that pump is at its limit too. So really what we're seeing again is that it's the circuit that's limiting our ability to pump that fluid. So if I go back to system info, what will the variable speed flow center do? We're seeing that the 26.99 and the UP 26.116 are limited by the pipe circuit, and we see the same thing for that variable speed flow center. But we're getting our flow rate. Our Reynolds number is so close that we could roll the dice, or we could vary our loop length a little bit, 4/10. And this, again, you have to respect what the GeoAnalyst program told you about your minimum loop length. We don't want to go here and put in a 200-foot horizontal bore just because it allowed us to select the pump that we had on the shelf. I'm not going below the minimum ground loop that GeoAnalyst had previously recommended I install for this unit to maintain the minimum loop temperature in the winter. Or for those of you that are in a cooling dominant climate, the maximum loop temperature for the summer. So I'm still respecting that, but I am going to go down to a 410-foot circuit and take a look at this pressure drop. So there we are. This is a variable speed flow center with a 26.99 pump to assist it. We have exceeded our nominal flow rate of 30. We are now at 32 GPM, but we did respect the Reynolds number, getting it just over 2,000. So it would take 41 gallons of antifreeze to do this. Now, I know there's someone else out there saying, why do I use propylene glycol? I use an ethanol or methanol or a GTF antifreeze. That is definitely going to be another helper in this scenario. So if you can do that, let's say the UP2699s, there's 2 of them per unit. Pressure drop chart's going to show us that it, of course, oh yeah, I changed the loop length. Sorry, I forgot that. So now, what we're seeing here is that propylene glycol in that ground loop setting with the 22699s per 5-ton unit will give us the desired flow rate, but doesn't respect the 2000 Reynolds. If you're a stickler on that and you can go to a different type of antifreeze, then go for it. Let's trade this out for GTF. Enertech sells a product called geothermal transfer fluid, and that is actually sold in 1-gallon jugs and also large totes. So my customers use large totes and they blend this stuff at 50%. That's what you need for a blend of GTF at 50% will give you the proper freeze protection for your ground loop. So this is a thinner antifreeze. I'm going to leave everything the same. The 22699s would previously give us the desired water flow, but they did not respect our Reynolds number. Now what we see is that by thinning the antifreeze out, it's a lot easier to flow. So this system has a higher Reynolds number, drastically. I mean, we're over 1,700 Reynolds higher than the glycol system was. It does take more fluid because we're blending it at a stronger blend, but that fluid doesn't cost as much as propylene glycol. I know in my area, we are required to use propylene glycol in all vertical loops. So I wouldn't be able to do this with a vertical, but I could do this with a horizontal bore or a slinky project. So just throwing that out there for you. You could play with the antifreeze. If we wanted to look at the same scenario, let's look at, I'm going to go with an ethanol-based antifreeze at 22%. Everything else stays the same. So this would be a product we sell called ProCool. And this here we would do 32 gallons a minute. And our nominal flow rate or our target flow rate is 30 GPM. So we are exceeding our target flow rate. This is an adequate pump and also has an adequate Reynolds number. So that would also be a good antifreeze to select. Please do notice that I have received an error up here at the top. Flow exceeds 32 GPM, which is the limit of this program. If you have a project that is over 32 gallons per minute, then you would definitely want to use the Loop Link program, which is what we're going to cover next week. But for the GeoAnalyst program, anything under 32 tons, as you could see, is pretty simple and pretty accurate, pretty cut and dry on what's happening with that system. So that's really the meat and potatoes I wanted to show everyone. Going to ask Noah if we've got any questions. Also ask Noah to, if there's not any questions there, we could possibly unmute the attendees and see if they've got any questions. Has anyone typed any questions into us, Noah?
I've not seen any questions typed in. I'll go ahead and unmute all the attendees, and you all can feel free to ask a question if you have one.
Yeah. And if anyone's in a loud area and they've got a lot of background noise, you might go ahead and mute yourself unless you're speaking and asking a question, since everyone will be unmuted here shortly.
All right, everybody's unmuted. Feel free to ask a question if you got one.
Not everybody at once now, one at a time. Well, Noah, either I put him to sleep or I covered everything very adequately. I'm not real sure. I know pump sizing and pump, yeah, right. Pump sizing and pump curves is definitely something that's a challenge, but when you understand that really all you're looking at doing is delivering a fluid of a certain viscosity or a certain thickness from here all the way through that piping circuit and back, what we've got to look at is just the resistance to flow. 30 gallons a minute, I need to send it through this piping circuit. I have 2-inch pipe, I have some 3/4-inch circuits, and I have this unit that I have to overcome the pressure drop of the heat exchanger. You could do it all longhand, and there are charts that help you figure that out, but all of that information is built into this program, and I think it's pretty fun actually to look at the different variables that affect the project and just be able to simulate what it would do with different pumps. The one thing that I would caution you against is just guessing. Definitely look at the program, look how easy it is to use, please use it, because after the fact, it's a lot harder to change your pump. You know, you can't just back up a screen and click a couple buttons. I've been out on some projects before that just didn't have adequate water flow, and a lot of heartache and headache could have been prevented had someone gone through and sized their pump with this program. So if anyone doesn't have any questions, I'm going to go ahead and close it up and let Noah wrap things up and give you a little commercial for next week. I think the Loop Link program is definitely the future. We have systems that are becoming more and more complex, and we have homeowners that are becoming more and more demanding because of these complex systems. The Loop Link program will really help you handle those very appropriately and document any homework that you've put into the project. So please sit in on next week's webinar. Noah will send out some information, I believe, unless it's already been done. And with that, I thank you for sitting in today and giving me your morning. Have a great day, everyone. Noah?
Hey, thank you again, Jeremy. Yeah, that seems to wrap it up pretty well there. If you guys have questions that you come up with later, or you know, as you're reviewing notes of the webinar, please don't hesitate to contact either Jeremy or myself. You can reach our inside sales department via email at insidesales@enertechgeo.com, or you can call into our general line 618-664-9010. And yeah, as always, you are more than welcome to give us a call if you have questions about anything. If you have texts out there, again, feel free to call us. We're here to help. Yeah, thank you guys for attending, and hopefully we'll see you at the Loop Link webinar we have coming up. And yeah, enjoy the rest of your week.
Thanks, Noah, and thanks, everyone.